Now, again, what we talked about the other day was our consecutive interior, or corresponding angles, alternate interior, alternate exterior, and consecutive angles. We talked about how these work with parallel lines, yes? Because if two lines are parallel, the corresponding angles, the alternate interior, the alternate exterior angles are congruent. They're going to be the same, yes? And our consecutive angles are going to be supplementary. They add together to be 180. So for us here, we went through the diagram and said that for corresponding, we had angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. And angle 4 would be congruent to angle 8. So for our corresponding angles, we're going to have 4 sets. When we're talking about 2 sets of lines that are parallel and a transversal that cuts them. The alternate interior angles would be our ones in the middle, so angle 3 and angle 6, because they're between the 2 parallel lines and on opposite sides of the transversal. The other set would be angle 4, which would be congruent to angle 5. Our alternate exterior angles, so it would be 1 is congruent to 8. So they're outside, they're on the exterior of the parallel lines and on opposite sides of the transversal. And the last one for this here would be angle 2 is congruent to angle 7. And lastly, our consecutive angles, our consecutive interior angles would be angle 3 and angle 5, and then angle 4 and angle 6. Now, we talked about exterior a little bit, which would be 1 and 7, and then 2 and 8. These would be our kind of consecutive angles. They're on the same side of the transversal, and either both going to be between the parallel lines, or both of them are outside. And we ended up getting these here, and we worked with these here yesterday. Because we worked with the properties of the fact that if they're congruent, we set them equal to each other and we can solve. If they are supplementary, or they're consecutive angles, well, we add them together and set them equal to 180, yes? And everything we did yesterday was revolving around the fact that we had 2 sets of what? Or 2 lines that were parallel, yes? Because if I have a pair of parallel lines, all of these properties hold true. Yes? Okay. Well, what we're looking at today, our first one, if 2 lines are cut by a transversal, or by a transversal, so that the corresponding angles are congruent, then the lines are parallel. We're going the other way around. So what we're talking about today and doing today is using the properties that we had the other day, or what we used yesterday, our corresponding angles. So if 2 lines are cut by a transversal, and the corresponding angles are congruent, then the lines are parallel. So we're going backwards, because yesterday we said if 2 lines are parallel, then the corresponding angles are congruent. Now we're saying that the corresponding angles of 2 lines cut by a transversal are congruent, then the lines have to be parallel. So what we want to do, and what we're going to do here and on the homework assignment, is show or find a value of x that will make these lines parallel. Looking at this here, the 3x plus 5 and the 65 degrees, those would be corresponding angles, yes? So if those corresponding angles are congruent, then what? The lines would be parallel, yes? So that's what we're going to do. We're going to set 3x plus 5 equal to 65 degrees, because if these two are equal, it means the corresponding angles are equal. And if the corresponding angles are equal or they're congruent, it means the 2 lines are parallel. So now we just need to solve for the value of x. Well, the first thing we can do is we can subtract 5 from both sides. And when we subtract 5 from both sides, well, 5 minus 5 will give us 0. So those cancel out, and I get 3x. Well, 65 minus 5 would be 60. And then we would divide both sides by 3. And when we divide both sides by 3, we get what? x is equal to 20. So if the value of x is 20, those corresponding angles would be congruent. And since they're congruent, it means the lines are parallel. Any other questions on this here? Any questions on this here? So this is very similar to what we did yesterday, isn't it? Concept-wise, it's different because now we're not assuming the lines are parallel first. We're wanting to say that the corresponding angles are congruent to show that they're parallel. Essentially, we're going backwards. Our process in finding the value of x didn't change, but the process we're doing did. Now, 72 degrees and 4 times x plus 5 are those corresponding angles. Well, one of them's above the line, the other is below it. This would be more of a consecutive exterior angles. So since they're not congruent, it means what? They add together to be 180. So to find out what value of x would make these parallel, well, I would do 72 plus 4 times x plus 5 is equal to 180. Because our consecutive angles theorem, the converse consecutive angles theorem, is really saying that if these two consecutive angles are supplementary, then the lines are going to be parallel. So looking at this here, the first thing we can do is what? First thing we need to do. We need to distribute. Because we have a number being multiplied by a set of parentheses, we need to distribute first. Well, that won't affect the 72. But 4 times x will give us 4 times 5 would be plus 20 is equal to 180, yes. I do not know why I wrote 100. It should be 180. I think I'm getting ahead of myself. So any questions on this so far? So all we did was distribute first. Now we can combine like terms. What are our like terms? 72 and 20. These would be our like terms here. So 4x plus. So 72 plus 20 would give us 92. Now because they're on the same side of the equal sign, we can just combine them. We can just combine them together. We don't use opposite signs unless we're trying to move something from one side of the equal sign to the other. When we're moving across the equal sign, then we would use the opposite signs, like we need to do now. Because we need to get the 4x by itself. Well, what's with the 4x? The 92. It's easy to do addition and subtraction first. So we would subtract 92 from both sides, because 92 minus 92 would be 0. It leaves us with 4x. Now 180 minus 92 would be 88. And lastly, we divide both sides by 4. And x is equal to 11. X is equal to 11. And that's it. That's all we have to do for this here. Because it's just asking us to find the value of x that makes these lines parallel. Now, I mean, we could have a question that talks about actually finding out what the angle measure is. Question?
How did you get 11?
It should be 22. Thank you. Thank you. I'm glad someone's paying attention to my numbers, because I get very much caught up in actually teaching it that I sometimes miswrite things. Yep. So again, I'm going to say this again and again and again. If something doesn't look right on a test or quiz or review sheet or anything that you know for 100% fact, you believe for 100% fact you got right, ask. Okay? I do make mistakes, and I will change them. Okay? So especially, I'm giving this right now, I'd say, especially on a test, how I do hand them back and I tell you to kind of look at the numbers, add them up, and make sure that it does equal the same thing, because on a test, I do circle and put a minus whatever on each page, add those up, and unless it's something different, if you add those up and subtract from 100, that will give you whatever your letter grade is over 100. If that number is lower than what it should be, tell me, I will recalculate it and fix it, okay? If it was supposed to be an 89 and it was an 87, I will give you those 2 points back, which ends up being 4 points in the grade book. If it turns out I gave you an 87 and it should have been a 67, you can tell me it's not going to lower. I will not lower your grade once you get that test back. Okay? Because whose fault was it for putting an 87 instead of a 67? Was it yours? No, it was my fault for putting down the wrong number, yes? I am not going to blame you or essentially hurt your grade for something I did. Okay? Once you see whatever the test grade is on your paper, it can only go up. Because if there's a mistake or error somewhere, I will correct it and it will go up. I will not lower it for some error that I did. Okay? Does that make sense? So I would make sure, especially when you look at the test, look through it and see. Ask. But it could be something silly like I just did here. Okay? So it's always good to double check it. Now, when we got done with that tangent, hopefully you're noticing most of what we're doing today isn't very different than what we did yesterday. It's just kind of going the other way around, yes? Now, if you remember back 2 days ago to 3.1 when we were talking about parallel lines, we had the street problem. And I said we couldn't tell that those one set of lines were perpendicular, or not or parallel, because they weren't mentioned. Do we now have a way to show it using these properties? Because if I can show that those two lines are two angles are supplementary, the consecutive angles are supplementary, or alternate interior, alternate exterior, or corresponding angles are congruent, we can now say two lines are parallel, yes? Mm-hmm. That's kind of handy. It's helpful. Because now, I mean, how could that be helpful? These are terrible stairs. But if I know, because we normally, when you build stairs, it's normally built like this, you don't actually build a full triangle. If I know at this angle, and they built a rail here, this angle here, and kind of with level, this angle here are the same, would the rail be parallel as the same as like the increase of the stair height? That's kind of nice, isn't it? To where now, if I was going to try to make a rail, I wouldn't have to measure the distance between this stair and the rail, and then this stair and the rail, to make sure everything's going up. Because if those two are the same, that has to be parallel. And this helps a lot in construction, because if we can make things and know that they are parallel or that they are perpendicular, it makes work easier. Because now you're not having to measure every little thing going up and down. So, now another part of the assignment is this here. Okay? Is what we want to say, and it's going to ask this on the homework, is there enough information here to say that these two lines are parallel? We have two angles, don't we? Are these angles, 75 and 105, are they congruent? Are they in corresponding alternate interior, alternate exterior? Now, what should they do? They should be added together to equal what? Because they are what? Consecutive exterior? So what is 75 plus 105? So is there enough information here to say that these two lines are parallel?
Yes.
Yes. Yes. And we can say consecutive angles, consecutive exterior if it gives you that option. Or really we could go and say that, well, 75 and this angle here are alternate exterior angles, so they're congruent, yes? So those would equal 180. Yep. That would be it there. So any questions on this here? So with these here, there's not too many of them because I only have one of them there. Is there enough information? So if we can say that the corresponding angles are congruent, then yes. Alternate exterior, alternate interior, any of these here, if we have enough information to say one of these here, one of these theorems, then yes. Keep deleting pages. Now, we can just look at this one here. I'm going to make one, let's say 73 degrees and 73 degrees, M and N. Do I have enough information here to say that these two lines are parallel? I have some yes, I have some no. Because 73 and 73, these two would be congruent, yes? Do I know anything else about the other line? So the other line can be doing whatever it wants, yes? So this here would be no, because we don't know anything about the other line. Does this make sense? Now, okay, I'm going to change it to this here. So did I change it from being no to yes by doing that? Let's take a look. So what, I'm going to draw in a different color just so we can see. So if these two lines were parallel, this 73 and this one here would be the same, yes? Because they're corresponding. That also means this would be 73, this would be 73, yes? And these two here add together to be 180, so we're good, right? What's 73 plus 73? 146, is that 180? Is there enough information here to say that these two are parallel? No, because those angles should be what? It should be 180. So this here really should be 107, because if that's 107, then it would work because, well, we could see that this would be 73, and now these two add together to be 180, yes? So if you have trouble seeing if they are parallel, kind of fill some of the information in. Fill in the ones that are congruent, and if it does line up that they are congruent, then yes. But here, when we had 73 and 73, we saw that that didn't equal 180. It didn't work. Any questions on this here? Now, I would just watch this because, again, like I said, I'm not going to make y'all do a paragraph proof. I probably deleted that slide. Okay, yes, I did. I deleted this slide by accident. So this here, I think it has it already down there for you, yes? It doesn't have these blanks. It has it written like this here. Yes. So this here, we've already used some of these. And really what they're saying, so two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. If the alternate interior angles are congruent, the lines have to be parallel. If the alternate exterior angles are congruent, the lines have to be parallel. The consecutive interior angles, if they are supplementary, they add up to be 180, then the lines are parallel, yes? So those are the theorems we had, but they were just flipped. Converse. Remember converse from last chapter? We switched the hypothesis and conclusion. Isn't that what we did here? Because the ones that we covered yesterday, if two lines are parallel, then the corresponding angles are congruent. So if the corresponding angles are congruent, then the lines are parallel. We flipped it. That's why they call these the converse. I think this is the actual next one, yes? because I ended up deleting a whole bunch of slides. Now, you guys won't have to do one of these. If you want to write the different proofs down, you can. You won't have one of these on the test. You won't have one of these on the homework. But I kind of want to show you this so that we can see, and you can see how we kind of prove that this is true. We're told, well, we want to show that the lines are parallel. Prove two lines are cut by a transversal so that the alternate interior angles are congruent. So really what we're wanting to show and prove is that the alternate interior angles are congruent, because if they are, then we can say that the two lines are parallel. So prove so that the alternate, so 4 and 5 are congruent, yes? Well, 1 and 4 are congruent. Well, I know 1 and 4 are congruent because 1 and 4 are vertical angles, yes? Vertical angle congruence theorem. Well, since 1 and 4 are congruent, it means 1 and 5 are, which means they're parallel. Which means they're parallel. So it's just a roundabout way of proving it, because we knew vertical angles. We started with vertical angles theorem. So 4 and 5 are congruent. 1 and 4 are congruent because of vertical angles. Therefore, 1 and 5 have to be congruent, and because of the corresponding angles theorem, the lines have to be parallel. Questions on this here? Now, I had 2 more proofs, but again, I'm not going to make you do any more of these proofs, because I know if I were a betting man, I would be able to say with 100% certainty, because I only bet if I bet at all on something that I have a 100% chance of actually getting right. I don't bet even if it's a insignificant amount that I could actually get it wrong. That there's only one person in this entire building that actually likes doing proofs. And I have a feeling that I could give you one guess and you could probably get it right. And it's not the other teacher across the hall. Yeah, no, I'm the only one that likes doing paragraph proofs, 2-column proofs, any proofs. I'm the only one that does in this building. I'm an oddball, I know, and I will accept it. So I'm not going to make y'all do any more proofs. The only way that you'll actually have to do proofs is if you go to a pure math college that does pure math. JBU's math degree does. Otherwise, you're not going to come across it until you hit your master's or graduate. So we're not going to make you do any more of that. But we are going to talk about the last thing here, this here. This is the last thing we're going to talk about, and then we'll have a problem, 1 or 2 problems. One of them is going to be dealing with the flag. This one here, if 2 lines are parallel to the same line, then they are parallel to each other. So if 2 lines are parallel to a third, they're all parallel to each other. So if P is parallel to Q and Q is parallel to R, then P is parallel to R. That's our transitive property, isn't it? So it works that if any number of lines, if they are parallel to each other, they're parallel to all of them. All parallel lines are parallel to each other. So looking at this here, if P is parallel to Q and Q is parallel to R, it means what? That P is parallel to R, yes? That makes 115 an angle 8. Congruent or supplementary? Supplementary, because these are consecutive exterior angles, yes? Consecutive exterior angles are supplementary. So I know that 115 and 8 add together to be what? 180, yes? Or I can subtract 115 from 180 and get 65 degrees. Because really this is the same as saying the measure of angle 8 plus 115 equals 180. Well, I can subtract 115 from both sides and get that the measure of angle 8 is 65 degrees. Same thing. Questions on this here? Questions on anything we've done so far? We good with this here? All right. Like I said, we're going to have a question with the flag. The United States flag has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. Let's see if I can, there we go. So why would they be parallel? Because all parallel lines are parallel to each other, yes? You don't have to write this because I don't think any of y'all would want to. Since the top line is parallel to S1 and S1 is parallel to S2 and S2 is parallel to S3 and S3 is parallel to S4 and S4 is parallel to S5 and S5 is parallel to S6 and S6 is parallel to S7 and S7 is parallel to S8 and S8 is parallel to S9 and S9 is parallel to S10 and S10 is parallel to S11 and S11 is parallel to S12 and S12 is parallel to S13. Therefore, the top is parallel to the bottom. That's the paragraph proof to show that this is true. Was I safe in assuming that no one wanted to write all that? But again, for doing the proof of this here, we'd have to state every single one of those is true.